The other day I took out my YF23 from Boxermad84 and I put all moving surfaces on this plane. Those are the rudderons on the back. They operate the elevator and rudders using the all moving surfaces. The nice thing about these all moving surfaces is that the throws can be much less than a standard surface. They're barely moving. I think this is 40% throws, and I can do loops and rolls and everything using them. And also the wind resistance is less. When you pull up on the elevator, it still maintains its speed very well. I didn't have to increase throttle much to get this plane to change altitude. So it's very low wind resistance on these control surfaces too. The thing is that they've got to be strong. And so what I've been doing for a couple years now on canards, the canards on my planes are up front here, and when I land in the tall grass, they used to get ripped off. So I've learned how to do a really good beefed up system on my canards, and I applied it to these surfaces here too. So as you see, I've got the control rod coming up through the rudderon here, and it bends backwards. The reason why I have it bend backwards is I found on the canards that if you don't have this bent backwards, then the servo is always fighting to keep the control surface centered. And it's got a lot of stress on the servo. The faster you go, the more stress you have on the servo. By bending this backwards like this, the pressure is being pushed backwards to this point here, and it's always centering itself in the airstream. So there's very little or no stress on the servos until you activate the servo. That's one tip. The other tip is that I use tempered steel rods. It's not worth it to try to use untempered steel. It's not even worth it to try to use carbon rods. I've done that and they just break, they snap. As soon as you have any kind of stress put on it, it snaps. Or if you bump it, if you hit it on landing, or the plane tumbles, you'll find that carbon fiber snaps very easily. The tempered steel does not, and it's worth it to have the extra weight of the tempered steel. Now on the bottom of the plane, you'll see the control rod comes through the bottom, through the center of a carbon tube. The carbon tube is a 2 millimeter inside diameter, and so is the steel rod. So it's snug in there. It's very snug, and it's important not to have any play. So as you see here, when I use the elevator here, you'll see that that rod is rotating inside the carbon tube. Now the carbon tube comes through, and I have it strapped to the side of the fuselage here with a plastic tie wrap, and then I have it heavily glued. And I also did reinforce the fuselage here with 2 pieces of foam just to make sure it's nice and stiff. You cannot have any kind of slop in the system. If you do, then you'll get the elevon flutter and it'll rip it off. And you can ask me how I know. You can see this glue mark here. The first time I put this together, I did not double this up, and it just pulled the back of the plane off. So that's essentially it. I've got the pieces right here. You can see the parts. I've got the metal rod. It's going inside the carbon tube. That gets put right inside here on the control surface. You glue that into that channel, tape it, and then down here I've bent the metal rod forward, and that's where you epoxy on, or I use JB Weld to epoxy on the control horn here. And that's exactly what we're looking at here. You can see the control rod is coming down through the plane, and that gets the control horn. So I hope that's clear. My head cam, the battery's dead in it, so I wasn't able to use too much of that. So I'm trying to do the best I can here holding my phone. But I think it gives you an idea of the way I did this setup, and so far it's been flawless. It's been great on the canard planes, and so far it's been great on this plane.